The theme of this session that's being hosted by Matthew Goldman of MediaKind, the new name of Erickson Media Solutions. What we're trying to do is make sure that everybody understands that this isn't just theoretical, it's actually real. So, Matthew, I'll let you introduce everybody in your panel. You can bring them all on at once or one
All right,
at a time.
Panelists, can we all go on stage here? You can pick any random spot you want.
Except that one.
Except mine.
Yeah, except that one.
I'm not even sure I'm going to sit. I might end up standing. I don't know. Let's see. Well, thank you all for coming to the IP Showcase to hear this panel. As Wes said, I have three very esteemed panelists over here, and I think I'll start real quick by having each of you introduce yourself, what your role is, your affiliation, and we'll move on from there. Thanks. Go ahead, Robert. You can start.
Hello, I'm Robert Erickson. I'm the Advanced Technology Director with Grass Valley. I'm just kind of focused on, very literally, what are we doing next in the industry?
Perfect. Mark?
I'm Director of Technology, Mark Seeger, Director of Technology for NEP in Australia. I've also lost my voice, so I'm going to do my very best to get through this session. We've recently completed an all 2110 broadcast, well actually two all 2110 broadcast centres and 4 100% 2110 IP trucks.
And I'm going to ask almost all the questions to Mark because he won't be able to answer them. So I hope you feel better, Mark. Thank you.
Thanks.
Go ahead. And Thomas?
Okay, I'm Thomas Edwards with Fox Networks Engineering and Operations, based out of Los Angeles. I'm in a research and development role within Fox NE&O.
Excellent. And I'm Matthew Goldman. I'm Senior Vice President of Technology with MediaKind, who you probably haven't heard of yet. That's because it's the rebrand, renamed Erickson Media Solutions Group. And we are very active in both the IP Showcase here as part of the demonstrations, as well as participating in the foundation standards in SMPTE, AMWA, and the Video Services Forum. So without further ado then, all of you are involved in SMPTE ST2110 deployments, every one of you. And some of these deployments are pretty substantial. In the move to this, what we're calling all IP, it includes many standards and specifications that were all laid out by what is known as a Joint Task Force on Network Media's Architecture. So if I'll just start with Robert down the end, we'll come this way. What have you seen in the case for Robert? What have you seen as far as implementations are concerned with how much of that JTNM architecture, so it's 2110 base, but it's not, there's more standards than just 2110, as you know. We have the PTP or SMPTE standard 2059, there's the AMWA NMOS specifications as well. So we'll start with you, then Mark will learn about what your implementation is because it's quite substantial, and then back to Thomas as well for Fox. Go ahead.
So for us, 2110, I don't want to say it was easy. Please don't, quote me as that. But what we've seen in our deployment has actually been the easiest part. PTP has actually been one of the more challenging parts for us. But as we're doing our deployments, really the requirement or the need for ISO 4 and especially ISO 5 has been the most important part for us. And that's the part that's been kind of lacking. And I think that's, if I were to say a current state of where we're at, we're showing ISO 5 here. So it's not that we don't have the standard, we don't have the technology. But getting all the vendors to get behind it, getting all the people to open up to that true open control. Because really for us, it came out to the transport was pretty easily managed. Getting the stream through the switches, getting a non-blocking multicast, that kind of stuff was there. But just getting all the vendors to communicate together through one common control system, one common interface was one of the biggest parts. PTP for us was one of the more pragmatic ones, just because there's a lot of little details you got to watch out for. But since that's based off of an IEEE standard that a lot of switch providers already support, that part came pretty quick. But some of the nuances of 2059 were definitely.
So we'll get into that when we dive deeper into some of the issues. Okay.
Yep.
But in the deployment you have to this question, then I'll move on to Mark. You're seeing that the implementation of 2110 is pretty common.
Yeah.
And using IEEE 1588 PTP, the SMPTE 2059 broadcast profile is pretty common. And you're saying you're starting to see the use of ISO 4 discovery and registration and ISO 5 control, but more work needs to be done there.
More work needs to be done. The functionality is there. We're showing interop here at the IP Showcase. But I would definitely say for mass adoption and mass scale use, we just haven't seen that really fully deployed yet. We've seen there's obviously a couple ways to work around it, but the idea is not to have to work around. Have everybody write to the common API, deploy that at massive scale. That's what the last part we're waiting for.
Fantastic. Now, Mark, we know that NEP Australia actually has quite a significant 2110-based deployment. So please take a few minutes to go and say what all the pieces of it are and what you have out there that's deployed.
Okay, there's actually quite a few pieces, and again, apologies for the voice. This time last year, I'll talk about this time last year because this time last year is pretty important. This time last year, we had an R&D lab running and a half a building built, no trucks and nothing completed, no tests were done. And 12 months later, we've now got 2 fully operational broadcast centres, running 7 centralised control rooms. The whole thing's built around centralised production facilities, bringing signals back using 2110 over a wide area network. There are 31 venues connected on that network at 50 gigabits a second, a couple of them at 10 gig. So we have a suite of SMPTE standards in use. Obviously, SMPTE 2110 is the biggest one, but we've got SMPTE 2042, we use VC2 as well, and of course 2059, PTP, everywhere. 4 new trucks were built, and 7 of the existing fleet were upgraded to IP as well.
So if I guess just for clarity on that, so the OP trucks themselves were upgraded to be 2110 base, and your REMI, or your remote integration facilities, are 2110 as well.
So the 4 new trucks are 100% 2110, no video cable, CCU, EVS, replay, graphics, everything is 2110. Those things have taken 12 months to get finished. Right? Not everything was 2110 this time last year. For us, the year's been quite interesting because we've migrated. All of the SDI is gone now. The last piece of the puzzle was VisRT that got changed out 2 weeks ago. So we're now 100%.
No SDI.
There is no SDI. Well, I'm telling a lie there, of course.
Of course.
There's some SDI. There's no SDI in the transmission chain, right? So
fair
the
enough.
chain from the CCU through the truck through to the hub.
Some of your monitors probably have to convert from 2110 to
Unfortunately, there's nothing
SDI.
you can do about that at the moment. There's a couple of monitors here too pricey. Why would you do it when you can just convert to SDI? So yeah, there's SDI at the edge, but the core of it, the core facility, and everything that goes around it is all 2110.
Fantastic. And you said you are using PTP to do the timing as well, right?
Absolutely. Yep.
And then how about with any of the AMWA, NMOS? Are you using those? Are you doing something else?
We're not yet. Not all the devices in our network are IS04 ready yet, so we haven't migrated to that. The servers are ready. They're implemented, ready to go. So as more manufacturers move on to IS04, we'll start porting ourselves onto IS04.
Okay.
At the moment, it's a very manual configuration.
Okay, but it's understandable because those are actually a little bit newer too in some of the history behind this. I mean, all of this stuff is, I guess everybody knows, it's all relatively new. And as you can see, like anything else that's new, it takes a while before you have the vendor base all picked up and implementing that. Thanks, Mark. We'll get back in more details on that. Thomas, so with Fox, where do you guys sit with 2110?
So I do want to do a quick history lesson.
I think that's fair. Go right ahead.
So,
of course, if you start, before the SMPTE epic, I'm probably not going to let you go back that far.
Yeah, I'll be negative.
Okay, there we go. All right.
10 years ago, we saw the first use of uncompressed HD video over IP when Level 3 began doing uncompressed over IP tests for contribution. 4 years ago, actually I say 5 years ago, a renowned SMPTE person said that we never send error critical stuff over IP. 4 years ago...
By the way, that wasn't any of us up here.
Wasn't any of you up here. 4 years ago, ESPN created DC2, their Digital Center 2, which was the first network center that was built completely around IP. Of course, they're using JPEG 2000 over IP, but it was all IP. And later that December, Fox Sports built the first uncompressed over IP OB truck with Game Creek. And this was something they did because the routing switchers on trucks were just getting too big, and they used the density of Ethernet switching in order to be able to bring the massive scale that they needed for modern sports productions like Super Bowl, like golf, into the truck world. So now any large truck that's built is generally built around a Ethernet uncompressed IP core. So 1 year ago, of course, we announced that SMPTE 2110 was complete, and this year, SMPTE 2110, all of the key uncompressed standards are published. So we are here now. And of course, I can say what we're doing at Fox has been we've been conservative, right? So we got an early Evertz EXE switch into our network center.
If I could just interject there, conservative in the rollout of it, but not conservative in thought, because Fox was one of the first said, I want to give them credit here. Fox was one of the first broadcasters that really said, you know what, we need to do this, and we need to do this as soon as possible. So maybe you're conservative in your rollout of it, but you were evangelist from the very beginning for on 2110.
Yes. I have to give my management credit. I don't know if
Richard was here before. Yeah.
But he and now Todd Daly have been supporting our R&D efforts. So we've got a Ethernet switch in our network center. We initially got it for monitoring purposes because, of course, half your cross points on your router in a network center are used for monitoring anyway, so it was easy to move that over. No air critical paths at first. Let it cook a few years, and it's been working fine, so now we have air critical paths over that. Unfortunately, that is still a proprietary protocol because we got it so early, and if it ain't broke, don't fix it, but we're working on that. Fox Sports, however, just got new Ethernet switches, which are all 2110 based. So this is used for our sports production on stages, for integration of sports games, and for our highlights. So if you're going to watch the NFL on Fox this season, all that stuff we do on the stage will be going over uncompressed using simply 2110. And in the greater Fox family, I hear that there is a build going on in South America, which I won't go into the details of, but is expected to be all simply 2110 as well.
Very good. So along the lines on that, one of the misnomers of this, to go all IP, people think of 2110. 2110 is a foundation standard that is at the, basically for the, if you split yourself into management, control, and data planes, it's a data plane standard, it's at the transport level. It's actually just one piece of this end-to-end puzzle. And as you heard us mention, there's several SMPTE standards that are involved here, not just 2110. There's a 2022 series that's involved here, which is, in many cases, is either SDI over IP or compressed video over IP, as well as a very important one that just got updated, which is 2022-7, which is the basically the hitless switching standard on that. It doesn't just work for 2022, it works for 2110. Maybe we'll talk about that in a few minutes. But we also, of course, as you know, we were talking about registration, discovery, and the control plane stuff that seems to need more work. But again, it's this whole family of everything that's gone together. So with that in mind, and I know there's some growing pains with the newness of the AMWA specifications, but putting that aside just for a second, because we'll talk about that more, is there anything else that you believe is missing in this whole ecosystem end-to-end that is not actually either standardized or specified now or in the process of being done? Do you think there's anything that's missing from this? Or is this an implementable end-to-end ecosystem? And this time I'll start with Mark, and we'll go to Thomas, and then end up with Robert. Go ahead, Mark.
The problem at the moment is it depends on your scale, of course. Because if you're talking about a small-scale facility, you're probably fine with ISO 4 and the suite of the standards that exist today. When you start scaling, you then have lots of issues, because if not all of your products support those things for discovery, registration, and control, you have issues. For us, we on the outset started with the belief that we didn't need orchestration. We had one single control system, because at the end of the day, that's what you want to get to, right? One control system, so you have one system that you set and configure and do everything in. We're not there yet. There are bits missing in the ecosystem still. ISO 4's not finished. ISO 5's not finished. So until that stuff is finished, it's sort of hard to piece the bits that are missing for our ecosystem at the moment, because we have a running system. But it's based around a control system and products that were built to work with that control system. So all our manufacturers that are in our ecosystem all had the foresight to put in the control protocols that we needed to be able to control the edge devices.
Okay, great.
We're in one single control system anyway. Discovery, registration, we're
right. So it's just the newness of it that you still, like everything else, you want to have everything under one control system, and we're not at the point yet where a single multi-vendor solution can do a single control system yet. That's something that's going to come along the lines. But do you believe there's anything missing is that just a maturity aspect of it in the time that the specifications have been out, or do you think there's some missing specifications on that?
From my perspective at the moment, I think that when everything is mature, there'll be a complete ecosystem.
Oh, there you go. Okay, that's really great.
I think that there's a lot of development still to happen, because
of course.
we struggle day to day with some of the stuff that's happening still. We've got, we have issues. It's not perfect by any stretch of the imagination. However, for the most part, it's been very successful. But if you look at what you have today, and you look at where we're going, the roadmap's behind us. If we look at where we're going, I think within the next year, I mean, look at the last 12 months, actually. The last 12 months is interesting. I look at the board that's on my left-hand side with the amount of manufacturers that are supporting 2110. I look at the board on the right-hand side that have everyone that's using it. That was half the size, less than half the size.
That's a really good point. So take a look, everybody that's sitting here, take a look at that wall over there. Although perhaps not every single specification that's being shown in here is represented by everybody on there, but I think it's pretty universal that everybody on this wall does 2110 and 2059. So the baseline transport of professional media, real-time professional media over IP, as well as the precision time protocol, clocking mechanism to keep things synchronized. Every one of those, and we're looking at 50-plus vendors participating in this. Thanks, Mark. So, Thomas, how about from your point of view, where Fox is sitting right now? Looks like you've got full 2110, or at least a core of that, in the centralized, and SDI is probably at the edge. But what about on the control system stuff? But you can talk about anything you want. I'm just saying, do you think there's something missing in the specification that because I know you're active on this, is not already at least either done in specification and being implemented, or the effort has not started yet?
Well, so to date, the systems that we've been putting into operation come from a single vendor. One vendor makes the Ethernet switch. The same vendor makes media gateways. The same vendor makes multi-viewers. The same vendor makes the control system, right? We've been lucky in that we've had a pretty good vendor to help us out with that. But at some point, they can't do everything. They don't make cameras. They don't make microphones. They don't make audio panels or video switchers. Right?
And you might want a second source.
You might want to have a second source. So that's where standards really come in. So it is true that we're missing what I call the full stack. And actually, John Myatt from Magic Communications will have a great talk tomorrow about the full stack concept. The full stack is 2110 with DHCPing IP addresses, with ISO 4 registration and ISO 5 connection management, and doing the things you need to do to fit into the ISO 6 network control, so that you can bring a device into your plant. And instead of I've got to break out my Excel spreadsheet and write down the IP address, and I've got to fire up a web GUI and go in and set what the video flows are going to be, all that stuff is insane, right? We should be able to bring in a device, put it in, DHCP's an IP address, registers itself, starts being ready to fire those connection management messages as they come in over the ISO 5 API. So that's what we need, the full stack of standards and specifications in order to make this all work. And the truth is that's the only way we're going to get wide-scale multi-vendor interoperability, and how we kind of get off those IP to SDI converters as we have more native ST2110 devices come into the ecosystem.
So along those lines, Thomas, I guess just for clarity for the audience here, obviously the implementation's not there yet, but do you actually believe there's actually pieces of the standardization or specification process that haven't at least been started to complete that end-to-end?
I think we've got almost everything.
Okay.
So as John and I have been looking at this full stack concept, we've been identifying there might be one or two places where we need a little bit of extra help, like how does the system know what its PTP domain number is? And that's something we could deliver
that's
through,
a good one. Okay.
through like a DHCP option. We could set that up, but we have to define that, right? So there are only a couple of places that I think we've got a few issues, but most of the stack is there and ready to go.
So, Robert, you had mentioned again that you felt, again, not that it was easy, but that all the pieces were in play and there was multi-vendors you could do it for 2110 and 2059. Yep. You mentioned some issues over control, and I'll ask you the same question. Do you believe it's just a lack of maturity in the market, or do you believe that there's some things that are missing?
Maturity, 100%.
Okay.
And I think recently, and I'm glad you brought it up on this one, Thomas, on the gateways, a lot of the reasons why we've gotten as far as we have today is it's actually really easy if you make the switch and you make the control system and you have your gateways to make everything work, because you own the whole thing. But our goal is to get away from gateways. Our goal is to get away from proprietary switches. And so that's actually where the complications come in. And now that we're having so many vendors like we're showing here with native 2110, the need for control is now paramount. Just having the transport stream does nothing without control. And so I think ISO 4 and ISO 5 is the tool set we need, but I think a lot more work needs to be done to accelerate our progress there, because questions about the scalability of ISO 5 to very large infrastructures, questions about scalability of ISO 4 to very large infrastructures, things like that that just require the maturity of the standard are where we need to go. We need to go there fast. You know, we poured so much effort into 2110, and we did such an amazing job of getting 2110 done as quickly as we did. I think that effort needs to be put in with ISO 4 and ISO 5, because without control, you got nothing. And that control is so much more important in an open environment when you're not doing proprietary infrastructures. And without it, there's no point in having the transport.
No, it seems like we're having, like I said, we're in that maturity phase, and some of this stuff is new on the control plane. But I do want to hear one thing from all you guys, because a way of doing this is the heck with having this thing be universal. Let's just have each vendor have its own proprietary control solution. Then it'll be done end to end. And there are a few systems in the marketplace that do that. So just want to hear from all three of you then, not necessarily a long dissertation on it, but so we're having some issues with this. Do you strongly believe, or maybe you don't, what is your opinion on, it's still the better way to go to have a multi-vendor based open standards and specification based control system on this, or do you think we should have each vendor have their own proprietary, just right across the road?
I'll speak from a vendor. I would love to have the entire ecosystem. I would love to sell every piece of gear in your facility.
We have a bit of honesty on the end.
Yeah, very honest.
You're about one of the only
behind my name
people
tag. As much as we would love that, the biggest thing is, though, is our job as an engineering company is to solve our customers' problems. And our customers may find solutions that they think is better than ours. They may find some other products that work better for their workflow. And we realize we're doing a disservice to our customers if we do a proprietary infrastructure. And so it does take more work to do open infrastructures. It does take more coordination to do open infrastructures. But if the end goal is to make to give the customers the tools they need to support the workflows they require, then it's a win. And so for us, you know, can we do an entire infrastructure based off Grass Valley? Sure. But that's not what our customers want. That's not what we want. And we're focused on that open part, although it does take a lot more work.
Granted. And Mark, since you got, like I said, you guys came out from nowhere a couple of years ago to being one of the largest real production-based solutions using 2110 for across Australia, and really from going from almost nothing just a few years ago to all new facility stuff based on that. So do you feel this way too? I know right now you have a single control system because it's necessary. If you want to make revenue, you have to do what you have to do. But do you strongly believe that the right way to go is with this open way of doing the control and management information?
Absolutely, it has to be. It has to be. Look, you know, it's great to have one manufacturer and only have one manufacturer and buy one set of equipment. You've got one, we call it choke to throw, throat to choke, whatever, where you go to one manufacturer, you have one issue. Mm-hmm. For us, the real world is out there for us. You know, we have a multi-vendor building. We have to. You know, we have various manufacturers in our facility, and, it has to be that way in the real world, right? So, you guys don't do every suite of products, and
Nope.
we want to buy everything from one manufacturer. It'd be silly. But in terms of control, we have one control system at the moment. Of course, there's very few single control systems outside of vendors that support multi-vendor support. It'd be nice to see the open standards pushed a bit further, for sure.
Great. Thomas? Mm-hmm. Go ahead, same kind.
Oh my God, we want the flexibility, right? Nobody really builds a plant completely from a single vendor, right? You might have a lot, but you always need to reach out to other vendors. Everybody has. Do you guys make microphones?
Absolutely not.
No. See, so not even the great Grass Valley, Sam.
Oh, the great Grass Valley.
Does not,
you get accolades over here.
does not make microphones, right? There's always something else you're going to need from somebody else, and eventually your plant always builds organically. And as a user, of course, we like to have no sole sources, right? That makes our purchasing people a lot happier when they can, call up one company and say, "Hey, I got a better deal than the other company."
Of course.
So, and that keeps the vendors honest. So that's really the direction we want to go. That's really what we want. I tell you that this becomes another issue as well, is that you guys don't make Ethernet switches either.
Nope.
Right? You leave it to the experts in Ethernet switching. We've got 400 gigabit Ethernet ports coming out this year. I just saw a 32 port of 400 gig switch, 1 RU. It's 8,000 by 8,000 HDs in 1 RU.
How big would that be if that was an SDI switch?
It wouldn't. It would not. There's never been an SDI switch
Physics don't
that's
really allow
8,000 by 8,000. I think maybe 2K by somewhere in the neighborhood of 1K by 2K or something, but never Never
And
that
how big
size.
would that have been, though? That would have been, what, 2-3 racks, right? You're talking 1 IU.
I hear it scales more than linearly at some point.
Yeah.
But anyway, so the IT industry with Ethernet is just cruising off, into terabit Ethernet land.
That is why we're doing this, by the way. Just to back up a little bit, I know we jumped into the panel at the beginning, but the reason why we're talking about moving to all IP to begin with is really leveraging off of the IT industry's scalability and flexibility. And it's not that the broadcast industry can't do it. We most certainly have. We've been doing it for 30 years. But what we couldn't do 30 years ago that we can do today is broadcasting is one of those industries, and there are several others as well, that really are 24 by 7 by 365 live operation where there's no such thing as a do-over. That do-over, if it comes at certain times, it could be critically different. When it's a live event, you don't want to miss that goal. You don't want to miss that person, stepping on the moon for the first time. All these great things in history that you rely on broadcasting being live and every frame being delivered. There is no retransmission on this. Either you get it or you don't, and it's done.
Well, if I can add on,
Yep.
Matt. So the other thing is, when it's pieces of hardware, there's almost a bit more of an understanding about the need for proprietary control systems. But the future is software.
Yep.
The future are going to be microservices deployed in containers into a broadcast data center, as needed, spun up, spun down,
Right.
and that will give the opportunity for a wide range of new vendors to come in. People who've got new innovative ideas, and all they have to do is sit in their home office and write the software. And that's when
just a small matter of programming.
small
No big deal.
Yeah, but you understand.
100% reliable, no downtime, fully secure, but that's okay. Because people do say that about SDI. They've changed the name to Secure Digital Interface,
Yes, right, exactly.
as opposed to IP.
Yeah. But I'm saying software is going to benefit from this multi-vendor interoperability more than hardware.
I do want to go back into the sophomore
Yeah.
detail. I just want to just wrap up for what I was saying a minute ago. So in this conversion to all IP, if you take a look at it, there's probably tens of thousands, maybe 100,000 broadcasters worldwide. So you're talking about hundreds of thousands, maybe 1 million pieces of equipment. When you look at the IT industry, it's not that they do it better, they do more of it. So we're probably talking, tens of billions or hundreds of billions of people using IT equipment, and you do the math, it's trillions. So that's somebody developing an IP over Ethernet backbone, an Ethernet-based backbone selling trillions of pieces of equipment. Who do you think is going to get the better economy of scale? That or tens of thousands of SDI? So we're not really bashing it. I just want to make sure we're not bashing the broadcast. We're just saying it's a fact of life that in order to be able to move into this new idea of using this virtualized software world where you have software-defined, in this case, not networking, software-defined media processing, where you can move the microservice and have it run on commercial off-the-shelf servers, you need to be able to leverage off of that. And standards such as 2110, for instance, it used to be we did SDI, we were defining wire waveforms at the physical layer all the way up to the application. Now you only have to go to the IP layer. So all the broadcast-specific stuff goes down to the IP. Actually, it's higher than that. It's at RTP. It's at the transport layer. And then everything else we leverage off of the either the IETF or the IP industry or off of IEEE for the lower stuff. I just wanted to get that out of the way of why we're doing that. To the next question, I'm going to start with Thomas and go across to Robert and then Mark. So these are all pretty big undertakings. So if someone is right now just thinking about starting, I'm going to go and I really want to either want to migrate to 2110 or I want to do a greenfield operation that's based around 2110, 2059, the MWAT specs. Knowing what you've just been through for the last couple of years, just name a couple. There's probably many. What are the few major things that you think people should know first as they're diving into this, that you wish you knew when you were first starting, or maybe as a hint, hey, this is what really helped us if we only had started it this way? Go ahead, Thomas.
Well, I think you've got to have the vendor prove out the solution, right? And if they can do that in their lab or they can bring it into your lab, I think that's a key element. The reliable distribution of PTP is still a little
Precision
tricky.
time protocol. That's the underlying clock. Yeah.
It's the black burst of IP. You need to be cautious in putting that together. And again, there's another situation. Go to your vendor and say, what happens if I pull this cable? Does the PTP still work, right? That's a good idea. And then think about how you're going to train your staff, because your staff is going to have to know more than just broadcast engineering now. Renard Jenkins from PBS calls his people BITs, broadcast IT people.
Figures that Renard.
Because you have to know,
both.
Yeah.
Have to know your bits.
Yep.
There you go. Robert.
Research. Do research. Know everything about your workflow, what you need to do. When we used to design infrastructures for SDI, all we had to do is say, you know what, I need 1,152 ports on the input, I need 1,152 ports on my output, and I know when I plug my coax in, I'm good to go.
That's the old hardware-centric world.
Yes.
Now you don't even know where your flow is going.
It didn't change much from the analog days.
Yeah.
It was
It's
the kind
just
of thing.
same thing, just digital, right? Yeah.
So now that everything is IP, everything is now a function of bandwidth. It's no longer a function of physical interface. It's no longer a function of anything like that. It's a function of bandwidth. So when you start to design your facility, sitting down and saying, I've got these devices that are going to be using this much bandwidth. Is it going to be 1.5 gig? Is it going to be 3 gig? Is it going to be 12 gig? If it's on a 25 gig interface, am I using one 12 gig or how many 3 gigs? Going through and detailing out every single connector of the facility and how much bandwidth is required is so important. Because one time, so much we've found in some of our earlier projects, people just assume this is kind of similar to building SDI, we're just using IP ports instead of coaxial ports. But no, it's all just a function of bandwidth. So that's a really important one. The second thing we found is, very much to Thomas's point, work with the vendors to prove it out. IP switches are not all the same. If you go and buy an Arista switch or a Cisco switch that it has not been designed to be a full non-blocking architecture, guess what? It's going to be a blocking architecture, and it will burn you. And we actually had troubles with that in the early days, where we had earlier switch manufacturers who said, oh, this switch is fine. And then we load that switch up to 50, 60, 70% load. Next thing you know, we have a cliff effect and the whole thing comes down. Not really good for that 24/7, 365 operation part.
No.
Very much.
But there was a backup switch for that, right? I'm just. Go ahead, Robert.
Too much to Thomas's point. Also, PTP. PTP has been one of what you think is the smallest, simplest amount of data on your network that is also the most frustrating.
And the most critical.
And absolutely critical. If switches can run in boundary mode or they can run in transparent, if it's boundary and you have XY networks and you have PTPs feeding both of those, but they're not in sync and then the system switches over, what happens? Or if you lose PTP clock on a boundary layer network and then the PTP comes back up, what do? Do you do a jam? And now everything glitches a little bit, or how do you resync the boundary layer to the PTP generator? PTP has hands down been probably one of the most problematic and nuanced problems of the installs. Absolutely. And then again,
so do a lot of research on not only which vendors to work with on the PTP, how well they do it, but also I'm assuming the architecture, the layout of your PTP, because one thing we haven't talked about here because of the nature of what this is here is we have what they call grand masters, where they're doing the master time, and then there's masters based off on that, and everything else is a slave, and there's a whole communication, and you can even set up boundaries of areas of control for each of the clocks, and if they get out of sync with each other, it can cause some serious problems.
Yeah, by the way, there will be good papers at the SMPTE conference in October
I love this, man.
on building redundant PTP solutions.
We are not doing our job if we don't do shameless plugs of other technical conferences.
Right.
So the thing on PTP is, just because you used a vendor for a reference clock in the past doesn't mean it's the only available one now. And what we've found is since IEEE 15E8 has been around for a long time, that there's actually a much larger pool of reference clock generators than we've ever had before. And honestly, a lot of them have already figured out some of the problems we're going through now. So don't just stick myopically to your current vendors you currently use. Now, some of the broadcast vendors are coming around and kind of figuring it out. But talking to people and talking to people you trust, vendors you trust, consultants you trust, other coworkers, other networks about what have you done on PTP is really important. So it really comes down to research is big. But the biggest thing I have to plead for is spend as much time and money as you can to train your engineers and staff.
First time we've talked about training, so
yes.
Except for the bit comment from
I like that comment.
I don't like that bit, broadcast and IT. I like
hands down, the biggest thing that we've had is every project we go into, we spend so much time training the customer, training the end user, training the engineer on what the technology is before we even build the product. And so what with those, they'll come in with their set of ideas, their set of criteria, their set of functionality, and then we go and say, cool, let's spend some time talking about how this actually works. And then a week or two later, the thing's completely changed.
Okay.
So spending any time, any money, anything you can on resources to your engineers, to your end users, to your operators, just train them about the fundamentals is absolutely huge.
You know who's got some good training courses?
Another plug.
Who?
SMPTE has some
has a
good
good-
training
Are
courses.
they available online?
They are available online. Go to SMPTE.org.
www.smpte.org. There we
Yeah,
go.
look under the education
Excellent.
section for some great, the IP in general as well as 2110 specific courses.
Yeah, they have IP for broadcast engineering courses, which is kind of nice. So if you're doing that, again, the nice little BITE thing, broadcast and IT engineers, BITE, there we go.
There you
So
go.
Mark, I know that you guys started from nothing, and you were intricately involved in this. So I can imagine along the way of implementing one of the world's first 2110 remote integration systems and OB truck communication, you might have come across a few issues you'd like to have people know that if they're going to dive into this, what they should do. And I realize that your colleagues in here have already mentioned some, which you probably shared some of those. Is there anything else perhaps they haven't covered that you'd like to mention?
Oh, it all worked first time.
Yeah.
I listened to the two guys on my left and my right hand side talk about time and, working with your vendors. And I'm thinking this time last year I didn't have any. I didn't have the luxury of time, unfortunately. So we did it all the wrong way around. We started with buying the equipment first to get the manufacturers to do 2110 for us, shipping all the equipment to our lab where it was supposed to work. So we went through a lot of hard yards. It was actually pretty tough. And the funny thing is, one of my senior network architects is in the audience here, okay? You're talking about PTP. He's laughing because we've been through all of this. We've pulled our hair out on PTP. It's been a complete nightmare. So, I would say, and I can say this now because we've been through it, and we didn't have our network design done when we started this. We didn't have our PTP design when we started this because we didn't know all the stuff.
Yep.
Right? There's a lot more information around now than there was 12 months ago. When we started this, there was nothing. We were starting from scratch. So you get your network design done the right way from scratch. You choose your right vendors and you know who you're going to work with. Give yourself the time that we didn't have.
Yep.
The truth is, I would have loved to have had more time, and I think we all would have loved to have had more time. Unfortunately for our project, we didn't have that luxury. And if you get your P2P right and you get your network design right and you choose the right vendors, it shouldn't be that hard now. When I started this, it was really difficult. I thought ahead.
That's called being the pathfinder.
Yep.
I think you're the definition of an early adopter, okay?
I think I am, yeah. I want to touch on the staff.
Go ahead. Staffing chef. Yeah, go ahead.
Because one of the biggest learnings, of course, and Tom will know this, is you try and get a traditional broadcast engineer working in IT, IP, and they haven't worked in it other than, configure a few switches for some low bandwidth stuff because we do that in the trucks, obviously, for control. I don't get it because that's not the sort of thing they're used to. We went into the IT space. We brought some very clever IT people in. We worked with them to get them involved in the broadcast side of the business. It's worked really well for us. So we have our bits, bytes, or whatever you want to call them working. There's 7 of them now. And it's actually working really, really well for us. But I now look at our facility and we're more of a network than a broadcast facility because the bulk of it is we're on Arista switches, we're on COT switches, right? So
Well, if you look at the broadcast center in, say, a couple of years, you can tell. How can you tell it's a broadcast center versus data center? It's going to look very similar.
That's the goal for a lot of
right?
people.
Yeah.
That
You
is
walk through our
absolutely the goal.
Yeah.
our rack room is a cold corridor. It's basically a data center. That's exactly what it is.
So here's the age-old question. You heard of the chicken and the egg. Which is an easier path? Taking a broadcast engineer and training them how to be an IT engineer, or taking an IT engineer and training them to be a broadcast engineer? This is more just for tongue-in-cheek fun. Anybody have comments on that?
I have comments on that, but I just talked about that. Look, it depends on the individual, right?
Depends on the individual.
It depends on the individual because there's some great broadcast engineers just got it straight away. I'm there, I've got it. And there's some great IT guys that got the broadcast side. You've got to pick the right people.
Okay.
I don't think there's one answer for that, by the way.
There you go.
I think the big thing is with the complexity of the network infrastructure we're doing with all the different protocols, standards between IGMP and all the SDN stuff, somebody has a really good concept of networking is absolutely key. If you can take that person and just train them with the immediacy and the requirements of the 24/7, 365 is the biggest part. You got to
I
find.
mean, you just can't just drop the packet and retransmit later?
Or you know what? We got a problem. I'm going to send IT an email, and they're
raise a
They're
ticket.
going to fix it in a
Get to
few
it
days.
now.
Yeah, that is a common problem here. Oh yeah, we'll get around to that as they're playing, Space Invaders.
Exactly.
On there.
And I think that's one of the biggest things is a broadcast engineer has always been trained that this is critical, mission critical, everything we do, 5.9 uptimes, no matter what. So the network guys have not necessarily had that because who cares if you drop a couple packets or who cares if a switch goes down for 5-10 minutes? That's gone. So if you can ingrain the traditional broadcast engineer's sense of urgency, sense of critical alignment into a network guy, there's your unicorn right there.
Excellent. Thomas, anything further, or if we beat this
Well,
to death?
I believe there is hope of taking broadcast engineering staff and making them bites, making them broadcast IT people. Of course, when you have unions, you may not have a choice. You have to do that.
There are
it is
complexities to doing some of
It
this.
is doable. It is doable.
Okay, great. So, just to try to turn the subject a little bit here, and now I'll start with Robert and just go straight across. So, based on what you've seen in this, now that you're implementing all, remember we said why we converted to all IP was for flexibility. In some cases, you can't have a large SDI switch just because it's technology that was developed in a time when you couldn't have software-defined anything. 15 or 20 years ago, at the starting of the twinkling of eyes of converting to a digital plan from analog. That's where SDI came from, because that was the state of technology. We couldn't just say, just run software on top of a commodity off-the-shelf or a commercial off-the-shelf COTS server. You had to have perfect purpose-built hardware, and now we're seeing some of the, you can't have a 4,000 by 4,000 switch unless it's software-based, right? So with that in mind, starting with Robert, from what you've seen, can you quantify any workflow improvements that you realize in the facility due to the change from traditional SDI-based infrastructure to 2110-based IP infrastructure?
When we first did IP, all the early adopters had to do it because of scale. I need to go to a truck that has X amount of multi-viewing, or I have a facility that has X amount of that. We're definitely to the point now where those who needed the scale have built the facilities out. Now the people adopting IP are going now to the workflow part, and the workflow is the most important part. And it all comes down to removing the physical interface. I was mentioning that earlier. Once we can get our media into the software domain, there's really nothing we can't do with the workflows. If you want to start applying new technologies, be it AI for image manipulation, or even the simple stuff of up-down cross-conversion, that's all completely different now. Your media no longer has to be in one location. You get it at IP, now you can virtualize it. So one of the big things for us has been saying, I want to get rid of all these racks of hardware that we've been buying that just does one thing. Well, we had to do that in the SDI domain because that one thing had one cable going into it. It did one job, and the one cable went out.
One goes in and one goes out.
Yeah. Right. So now that we have the ability of accelerated FPGA platforms and the ability to do a lot of the up-down cross-converge and processing functions in the software domain, opens up the ability for massive centralization, raising the quality of the overall video if you want to go that path, or even having facilities that are a rack of servers and a couple network switches, and there's your flyaway kit is there. So this opens up the possibility of enhanced workflows with the same quality we've traditionally had, with lower barrier of entry for capital costs, things like that. But the biggest part is the flexibility. Having that modular architecture open, this comes back to our earlier discussion of open. If you don't adhere to those open protocols, not anybody can just write software to process that media. Again, we've removed the physical interface, so why not just write the code to have a very easy to interact with solution.
Mark?
So biggest improvement for workflow, if you go to IP, or one of them, resolution. We've just gone from, we built the hub, it's finished, it's HD. Client last week said, hey, we want 4K.
Yep.
Guess what? I didn't have to change my infrastructure.
I think you should really emphasize that a little bit more. See, in the old system, there were, because SDI, and again, the nature of the beast from designs that are hardware-based from 15, 20 years ago, and doing it from the physical layer up to the application layer, designed through that, there's a separate SDI standard for every speed in every format.
Yep.
Now, if it's just a generic container that's encapsulating it, and you can put a label on it that says what you're carrying it, and that underlying structure is, say, dark fiber that you're running some of this Ethernet switches on. Now, all of a sudden, it's HD and 4K ready at the same time. It's what you're, as long as the speed domain is there. Because the data itself is generic. Right.
It's a function of bandwidth.
Yeah,
Again,
so I mean,
yes,
we have to add some more.
I think that's a very good point, Mark.
More network ports, stuff like that. But the underlying infrastructure doesn't change because things
that's
scale.
key. That's
you can
key
scale,
point.
and that's the biggest change for me. Because workflow improvement is the fact that one, it doesn't matter about your resolution anymore. It doesn't matter about your frame rate. It really just matters as a feature of bandwidth, and it doesn't matter where your equipment is anymore, as long as you have the bandwidth connected to the equipment wherever it is. So for us, we've got equipment shared across Sydney and Melbourne. There's 100 gig connecting the sites. We share the resources. If I need an extra multi-viewer because it happens to be in Melbourne, I just use it where it is. I move it, I ship it, move it, do anything. It's just there. So we have a decentralized environment now because, again, you have that workflow improvement. When you talk about IP, you get that. So it's a massively positive thing when you start to scale. You can't do that in SDI. You buy your 56 squared router, your 500, whatever it is. That's what you got.
Yep.
So, that's my take on it. But,
Oh, yeah, excellent. So we got the switch and the flexibility of the different types of. It comes down to just bandwidth available as opposed to the video format. Thomas, anything further to add regards to efficiency and workflow that you can quantify moving from the SDI plant to the 2110 base plant?
Well, at about 4K, 4x3 GSDI is the biggest pain in the world, right? It's
you get your
completely-
phases the wrong way around, quadrants the wrong place.
It's gonna drive you nuts.
Well, just put a 12G plant in there.
Yeah, well, there are only so many large 12G switches, right? I think there will be some because 12G is useful for some applications, but there's a limitation to how big those are right now. But there's no limitation in IP, obviously. I think the other thing is just
Well, the limitation gets moved to Ethernet.
Yeah.
See, so in the same way, I think this is a good point, if I may. The same way that now the SMPTE standards for transporting data are leveraging off of the IETF standards to get a generic transport, the IETF standards, as is traditional for broadcasting, are leveraging off of the IEEE standards for Ethernet. So we'll design a generic container, and you just give us higher performance stuff as technology at the lower layers comes to bed, and all the higher layer protocols stay the same, right?
And the density of Ethernet helps in other ways. So if you have a 100 gig Ethernet port, you put that on a pair of fibers and you bring it to a stage, and that's 50 or 60 bi-directional video streams.
Pretty incredible.
On a single pair.
Actually,
right?
it's about 80 in 2110.
Huh?
Very efficient.
Yeah.
About 80 in 2110.
Okay.
If you get rid of the audio and get rid of the dashboard.
Yes, exactly. So
And you might want a second one for redundancy through a different way, but that's
Yes, you definitely want a
But that's
second
for high
you don't
availability.
get that in SDI either, do you? You don't get the redundancy level in SDI.
That's right.
It's one thing that connects to one device and it breaks. Well, it's gone.
Yeah, 2022-7 gives you hitless failover. So that's the way to go.
We can bring 2022-7 in this conversation on that note. So, are any of you guys using 2022-7, which is the SIPTE standard that came out about 4 or 5 years ago, that was mostly around for SDI over IP at the time to do hitless switching. We could switch on a video or on a aligned audio frame, and you didn't drop anything. It went through in that. You did a lot of preliminary work on that. Now, of course, it's just been updated with SIPTE. I don't know if it's been published yet, but it's near close to being published. We're this close to publishing it, where it's really the same standard, but the language has been genericized, so you don't think it has to be 2022-6 base. It can be 2110 base. So, do any of your systems use -7?
We're seeing almost 100% of our RFPs coming towards us from customers are asking they require 2022-7.
There you go.
There is one area that is a little different, though, is some of the trucks are willing to take the chance and not go 2022-7. A lot of people are asking for it, but the OB market's one area where we haven't seen, but for fixed facilities, 100% are requiring. But one part that I will throw in
And by the way, just if I could, if you guys all turn around for a second and look at the wall, there's a whole demonstration of what SIPTE SD 2022 did. Oh, and Rick, our wonderful model back there, is showing what it's like to have link redundancy and data loss
Hey, Rick,
protection.
disconnect
Don't quit your day job, Rick.
Disconnect the cable, Rick.
Actually, you could do the demo live and disconnect
Yeah,
the
he's there.
cable.
Disconnect
Boom.
the cable. All right.
Disconnect the cable, and we
And
got
it's still
link
working.
out.
Woo!
It's still going. Boom,
All right,
boom.
can you
Oh,
disconnect
that's
the other
fun.
cable and prove it's not just a magic trick? It's there you go. Woo! Hitless failover.
If we
All
do
right.
both, I hope we get black screen on the
Yeah,
output.
otherwise
right?
it is a bit of
Anyways, go ahead.
One thing to complicate the discussion just a little bit, though, what we have seen is a lot of our initial facilities said we must have full 2022 DAS redundancy across every input and every output of the entire facility. What we've actually seen now is a few of our customers, after the build is done, said, you know what, we overbuilt. We overbuilt our redundancy. And the fact that we have two completely identical scaled network switches for redundancy wasn't necessarily needed, because they took an analysis afterwards and they realized that, there is critical paths that had to have redundancy. But not everything. The multimeter feed in the general manager's office doesn't need that. And they went through and they actually identified...
You sure the general manager agrees?
Well, he does when he sees the bill difference between the cost of the switches. So to complicate the discussion a bit, what we are seeing is now that we have some maturity in the installations, that people are taking a critical analysis of, do I actually need 2022-7 on every input and every output of the network? And a lot of people are starting to say, no, I can save some money.
Anybody else?
I can talk to that actually because we're 2110 hitless, so we're basically, we're 2110 because we own obviously essences separately because of the way we run our business, and it's a broadcast facility, not necessarily a plant center or a traditional broadcast facility in that sort of terminology. For us, we're going through that right now because we have full redundancy everywhere, from the camera CCU through the truck, through the delivery, back to the hub, through the hub, back to the broadcaster. All the multi-viewers are all redundant. Everything's you're right. Why? I'm wasting switchboards, and so we're going through that rationalization right now.
Yep.
What needs to be hitless and what doesn't.
And that rationalization comes down to just, again, to if you can get most of the coverage that you want and at a lower cost point, it helps in your facility at the end of the day. So that's what this is all about. Well, you know what? I'm pretty excited here that we have a very captive audience for 50 minutes of nonstop badgering of these guys. We're not done. I have more questions, but you know what? I'm going to throw the questions away, and Wes has a microphone over here. I know you've just heard us banter for 50 minutes. Do you have any questions you'd like to ask the panels? Please state your name, who you work for, etc.
Okay, Mike Dono, work for Corel Broadcast Training. My question is, do you think the fact that ISO 4 and ISO 5 are not standards, whereas the SMPTE 2110, etc., are standards, is partly responsible for their delayed take-up because manufacturers maybe are worried that they're not pinned down enough yet?
That is an absolutely excellent question. Thank you for bringing that up.
That's a really good question.
Yeah, I can speak from the side. We actually, being part of AIMS and also working along with the JT.
Explain who AIMS is, just so everybody knows.
Oh, apologies. So AIMS is an Alliance for IP Media Solutions. And what that is that's an industry group of a lot of vendors and a lot of end users, customers have kind of come together and said, this is the roadmap we need to succeed. And so by committing to AIMS as a vendor, we've committed to the roadmap set forth by AIMS, which is also copied from JT&M. And so ISO 4
the Joint Task Force on Network Media.
Sorry,
acronym.
I'm just throwing out
We're doing a lot of acronyms.
So sorry. So since ISO 4 and ISO 5 are on the Joint Task Force roadmap, which is also what AIMS has adopted, we are committed to doing it. But it's actually not just an industry affiliate that said this is what we have to do. The customers have told us we must have an open control API. And so when they say, hey, here's a $6 or $10 million facility I'm doing, and if you want any chance of winning this, you're going to have to put these protocols on there, guess what? We're going to put them on there. And so a lot of it's a commercial and also a political reason that's been driving the manufacturers. And not just Grass Valley, but you can see everybody on this board here is committed to that because AIMS and JT&M has put that on the roadmap.
So just to back that up a little bit to help you out with it. So AIMS obviously is one of the major hosts and sponsors of this illustrious IP showcase. Four of the other ones are on the back wall, which are the founding members of the Joint Task Force on Network Media, which is AMWA, the Advanced Media Workflow Association, EBU, the European Broadcast Union, SMPTE, the Society of Motion Pictures and Television Engineers, and just as full disclosure, not only am I work for MediaKind, but I'm actually the president of SMPTE at the moment, which is the volunteer position that's been elected. And then we have the Video Services Forum as well, VSF. So these four industry organizations saw the wherewithal back in 2012, 2013 to say, hey, there's more than one way to go to IP. We already have some initial stuff for doing SDI over IP, but that's just a transport. We really need to go all the way and really leverage off of information technology. And they got together. And as we're doing this, understanding the value of it, that's how AIMS formed. The Alliance of IP Media Solutions was formed as a market advocacy. These other groups are either industry forums or standards bodies, and they're focused there, but we need someone to advocate for it. So they directly go towards it. There's nothing, it's not that it's planned now, but there's advantages and disadvantages to doing a software incubator work, which is what AMWA does. The advantage is obvious right up front. You do something, you work on it together, you get a bunch of really good engineers across the table from the other, literally coding, the SDL level or whatever else, getting the interface work. And what do? They immediately release it to the market, almost like the way open source works, lets everybody play with it. You get access to it from a GitHub, and you can play with it. That's the great thing, so everybody can leverage that. The bad news is maybe that's not as mature and stuff, and you're relying on people volunteer to do that. But there's no one is better than the other. The difference is, like for SMPTE, which is a due process standard, is it forces a rigor on the process, which also by very nature means what? It's going to be a 2 to 3 year process for doing it. Now, Wes just said slow, but if you take a look at it,
you're going to
from
come all
SMPTE
fired up right now, by the
2110,
way.
ISO 4 and ISO 5 have been almost 2 to 3 years in discussions
Absolutely,
now.
yeah.
So I think the slowness, misunderstanding with due process, different ways. And by the way, once these things settle down and get done, there really is nothing stopping AMWA from going to SMPTE, hey, will you standardize this? Because that's really, if you take a look at the roots of 2110, now this isn't in all cases, but the core of 2110, the roots of that was actually work that was done by the Video Services Forum that was brought to SMPTE for standardization. So it can happen. So I hope that was helpful information for you.
If I could add one more to that too, and I think traditionally vendors have been resistant to adopting protocols or transports or whatever that weren't a standard because we were writing hardware to do it. We had to spin a board to do a transport.
Fair enough, yeah.
And now that we're in the software domain, if things change a little bit in ISO 4 or an ISO 5, it's actually just a software fix for us to be able to implement that.
Here we go again.
It's
It's just a small matter of programming, no big deal.
But I would say our willingness to take a more accelerated approach or even a more risky approach to standards or to different protocols is better now because I don't have to spend $500,000 or $1 million to spin a board because a protocol changed. So that's been a large part for us.
Do we have another question from the audience here? Anything? Anybody all? Don't be shy. Don't be shy. Bueller, no.
All right.
Nothing else? Well, we only have a couple minutes left, so at this point in time, I know I'm probably exhausted. My panelists said this was definitely one of those, lightning moment panels. We just throw a bunch of questions out. So please join me in giving a hand to these great panelists answering these questions. I hope you found this session very useful. Thank you very much.
Well, thank you, panelists. Thank you, Matthew, for organizing everything.